Homework 14, section 7.2, applications of the standard normal distribution, video 1. In the previous series of videos, we discussed a normal distribution curve and a standard normal distribution curve, and we talked about how to use a Z distribution table to calculate areas under a standard normal distribution curve. Recall that a standard normal distribution curve, by definition, has a mean of 0 and a standard deviation of 1. But the problem is most real-world situations have neither a mean of 0 nor a standard deviation of 1, such as this example. So how can we use the standard normal distribution table to do a non-standard normal distribution problem? Let's start by reviewing a z-score and how to calculate it. In this example, the mean term for pregnancies is mu equals 272 days with a standard deviation of sigma equals 9 days. And we'll start by just finding the z-score for a pregnancy term of 280 days. Recall that the formula for a z-score is z equals a fraction. On the top is x minus mu, and on the bottom is sigma. The mu and the sigma are just the mean and standard deviation of the normal distribution, the bell-shaped distribution. But the x is a given value. So in this example, the x would be 280 days. That's the value that we're given. So to calculate the z-score, in the numerator, we would do 280 minus the mean, 272. And in the denominator, we would have the standard deviation, which is 9. And then just do the calculations. The subtraction problem's difference is 8. And then 8 divided by 9 is 0.8 repeating. Or if you wanted to write it out, some 0.8888 ... Now, because our z distribution table only requires z's to be measured accurately to 2 decimal places, we will frequently round z-scores to 2 decimal places. So if we look at the third decimal place is an 8, which means the digit to the left of it will round up, and so we would say 0.89. Also recall that what this means, what a z-score means, is that 280 is 0.89 standard deviations above the mean. You can tell it's above the mean because the z-score was positive. If it ended up being negative 0.89, then we would just say 0.89 standard deviations below the mean. So calculating a z-score is pretty straightforward. It's just this formula, and its interpretation is it measures the number of standard deviations above or below the mean.